Good morning, pre-calculus students. Today is my first of one of 3 videos that will lead up to fully understanding the unit circle. You are doing most of your information on the unit circle through Khan Academy. I assigned that to you, but I think it's so very important and super cool that I like to show you the pieces of it myself too. So this is the first of 3 videos, and you will be taking notes on these videos. You will be pencil and paper, typing if you want. That's a little harder, but you will be uploading these to me at a later date so I can see that you took these notes with me. So these are special right triangles. These will look familiar to you. You use these, you learned them in geometry and maybe touched on them also in Algebra 2, but they're so important that I am looking at it also. We will use this in trigonometry and more specifically the unit circle. We use this a ton in Calculus AB, and that's why I am emphasizing this. Some of you will not go on to Calculus AB, but notice the name of our class is pre-calculus, and so it is my job to get you ready for calculus, and that's why we're looking at it. So what I need you to remember is that cosine of an angle is the adjacent side of a right triangle over the hypotenuse. Sine of an angle is opposite side over the hypotenuse, and tangent of an angle is the opposite side over the adjacent side in a right triangle. And you have seen that a few times. And again, boop, 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 you must take these notes. So let's come on over here and let's look at our first special right triangle, a 45, 45, 90. You could probably even tell me what both of the special right triangles are. 45, 40, 90, and then a 30, 60, 90. You probably remember those. So when we are done, this information we fill in, later you will see on the unit circle again. That's why we're looking at it. So I drew a picture here of a 45, 45, 90 right triangle. And notice what I've done is we know the hypotenuse is the longest side. And notice that I'm saying that that side is a length of 1. It doesn't mean really that it's 1 inch or 1 foot. I'm just saying it's 1 unit. It really can be as long as it wants. 1 foot, 1 inch, 1 centimeter. It's 1 unit. Okay. Now let's look at the 2 legs here. Notice they are shorter than the hypotenuse. Notice I don't know how long they are, so I'm going to call this leg X. And of course, because these legs are the same length, because the base angles are equal, this side must also be X. That's why this is called a special right triangle, because just by having one side, I can find the other 2. In other right triangles, you need 2 sides to find the third. Let's do the Pythagorean theorem, right? So I'm going to square one leg, plus I'm going to square the other leg, and when I add them up, that equals the hypotenuse squared, and 1 squared is 1. So here's the Pythagorean theorem. Okay, notice that these are like terms, x squared plus x squared. I have 2 of those. And now I'm going to solve for x. I'm going to divide both sides by 2. X squared equals 1/2. And I'm going to take the square root to solve for x. Now, many of you may say, well, Ms. Culver, don't we need to put a plus or minus in the front here? That's smart of you to remember. In this case, we don't, because x is a real length of a side of a triangle. It would only be positive. It would never be negative. So let's go ahead and take the square root. The square root of 1 is 1. And the square root of 2 is not perfect. Now this is perfectly true and acceptable, but we're going to write it in an equivalent form like you learned in Algebra 2B, and we're going to rationalize the denominator. And we get 1 times the square root of 2 is the square root of 2, and square root of 2 times the square root of 2 is 2. There we go. So that would mean our sides then, if our hypotenuse is a length of 1, must be the square root of 2 over 2. Okay, Now let's go on to find cosine, sine, and tangent of 45 degrees by using our information over here on the right. Here we go. So cosine of 45 degrees, we can look at either angle. Let's just take a look at the bottom one together. Cosine of 45 degrees is the adjacent side over the hypotenuse. So the square root of 2 over 2 divided by 1, of course I don't need to show dividing by 1. Class, if in your calculator, in degree mode, if you typed in cosine of 45 degrees, you would get a decimal that is equal to the square root of 2 over 2. Let's go to sine of 45 degrees. That is the opposite side over the hypotenuse. Notice we have the same thing that we did for cosine. Tangent of 45 degrees is the opposite side divided by the adjacent side, and notice both the sides are the same. The square root of 2 over 2 divided by the square root of 2 over 2 must be 1. Again, if in the calculator you type in tangent of 45 degrees, it's going to give you a 1. This is where it comes from. You will see these values on the unit circle. Let's go over to a 30, 60, 90 triangle, our second special triangle. Now the reason why I have more going on here is I actually started out with an equilateral triangle where each side was 60, right? And of course each side is equal. I dropped an altitude or a height to the base, and of course that made a 90-degree angle. Due to symmetry, it cut the top angle in half. So this is 30 degrees and this stays the 60 degrees. So class, we are just looking here in this right triangle, right? So notice what I did is just what I did over here. I made the hypotenuse a length of 1. Again, it doesn't mean 1 inch or 1 centimeter, it's just 1 unit. Now let's take a look here. In this 30, 60, 90-degree triangle, here's what we know. We know that the angle of 30 degrees is the smallest angle, and so it has the smallest side opposite it. We don't know how big it is. We're gonna call it X, okay? But wait a minute, don't we actually know how big it is? We do, because take a look. We said that each one of these sides of the equilateral triangle was a length of 1. And we said when we dropped this height that due to symmetry that it cut this angle in half. So it also cut this side of 1 in half. And so, Bill, how long is this side right here?
The half side?
Yes, it's
Yeah.
1/2. Awesome. So we actually do know how long that side is. Excellent. So now we have two sides of this right triangle, and we are going to try to find the side that is opposite the 60-degree angle. So let's use the Pythagorean theorem again. We're going to square one leg, plus we're going to square this leg, right, which would be 1 squared would be 1, 2 squared would be 4, and when we add those up, that would equal the hypotenuse squared, which is 1. There we go. Bill didn't know he was going to be included.
No.
Bill.
You threw me under the bus there for a second.
Bill, I'm going to subtract a 1/4 from both sides. What is 1 minus 1/4?
1 minus 1/4, 3/4?
Yes. Thank you.
Throwing me under again.
Sorry.
Too early for that. Okay.
He hasn't had his coffee. We're going to take the square root of both sides, and we get that that side is the square root of 3 isn't perfect, but look in the denominator. The square root of 4 is perfect. It's a 2. And this side would be the square root of 3 over 2. Okay, so let's clean up our picture a little bit, and we're going to fill in cosine of 60 degrees, sine of 60, tangent of 60. And then we're going to do cosine, sine, and tangent of 30. Okay, so let's just clean it. Here's where we're looking. We're going to do a little erasing. There we go. There we go. We're just looking at this special right triangle right here. Now, let's start with the 60-degree angle. It is circled in blue, and cosine of 60 degrees would be the adjacent side over the hypotenuse, and 1/2 divided by 1 is simply 1/2. Again, class, if in your calculator you put in cosine of 60 degrees, it would give you a 0.5. Let's look at sine of 60 degrees. Sine of 60 degrees would be the opposite side over the hypotenuse, which would be the square root of 3/2. Now, tangent of 60 degrees is going to take us just a little bit of work. That would be opposite over adjacent. So I'm going to come on down here. That would be the square root of 3/2 divided by 1/2. So when we divide fractions, we're going to multiply by the reciprocal instead. Notice the 2's cancel out, and we get tangent of 60 is the square root of 3. Again, if you put that in your calculator, you would get a decimal equal to the square root of 3. Again, you will see these values on the unit circle. Let's go over to cosine of 30 degrees. So we're adjusting our focus to the angle at the top now and renaming the sides opposite and adjacent, and of course the hypotenuse is the same. There we go. So let's do cosine of 30 degrees. Cosine of 30 degrees would be adjacent over hypotenuse. Notice that would be the square root of 3/2. Sine of 30 degrees would be opposite over hypotenuse, which would be 1/2. Tangent is the hardest one. That would be opposite over adjacent. In this case, it'll be 1/2 divided by the square root of 3/2. That's going to take us a little bit of work. 1/2 divided by the square root of 3/2. We're going to do what we did before and multiply by the reciprocal. Notice the 2's cancel, right? And we are left with 1 over the square root of 3. A perfectly true answer, but we are going to rationalize the numerator because this is how the values appear on the unit circle. So we have 1 times the square root of 3 is the square root of 3, and of course the square root of 3 squared or times itself would be 3. And this is the actual value of tangent of 30 degrees, the square root of 3/3. There. So be sure to have these notes handy for when I ask you to submit those to me. And it's important that you remember when we look at the unit circle that these are where the values are coming from. Thank you and have a great day.